Hello my dear students, I welcome you to NEET World. So this is our 100 days challenge for NEET, JEE and EAP set 2026 preparation, right? Okay, so in this session we will be discussing about redox reactions and particularly about few questions related to finding oxidation number, and then next we will be discussing about what are the important types of redox reactions we have, and after that we will be looking into the balancing of redox reactions. Okay, so these are the important topics, you must be aware of this, and let us discuss on this. Let us start our discussion. First of all, based on previous class, okay, previous class what we discussed, so we have studied about finding the oxidation numbers, right? So how do we find the oxidation numbers? For example, here we have sulfuric acid. Okay, let me give you one basic idea, then later I will be showing you few questions on this. Okay, now I want to find the oxidation state of this sulfur. So how can we do this? So consider, let us consider the oxidation state of sulfur as X. That is a value which we need to find here. So X is the oxidation number for sulfur we need to find. Overall molecule is a neutral molecule, consider that. Okay, so now here how many hydrogens are there? 2 hydrogens are there. So we know finding oxidation number, so this is based on what? Based on what? Electronegativity difference, giving the oxidation number based on electronegativity difference. This is the one thing you need to remember. And one more thing, after knowing this electronegativity difference, for few molecules we need to also consider their structure. Okay, these are the two factors we need to consider. Shalini, hello dear. So I hope you will be following the class. Okay, so if you have any concerns or any difficulties in understanding the concepts of this redox reaction, feel free to ask in the chat box. Okay, I will address them. Okay, so now what are the two things we need to consider? One is electronegativity difference and other one is structure of the compound. Okay, for example here sulfuric acid I am writing. I will tell you how to generate this formula. Before that, so you need to know the structure of molecule so that you will get full clarity on this. See, sulfuric acid is something like this. Okay, something like this. Okay, so out of this, tell me sulfur oxygen, which is more electronegative? Oxygen is more electronegative, na? So the number of bonds attached with the sulfur atom will be taken towards oxygen. Why? Because oxygen is more electronegative. How many bonds are there? 2 bonds. So with respect to these 2 bonds, oxygen will get -2 charge and sulfur will get +2 charge. Hope it is clear. Similarly, this downside also, this oxygen will take these 2 bonds towards itself because of more electronegativity of oxygen. So this oxygen will get -2 charge, sulfur will get +2 charge with respect to these 2 bonds also. Here if you consider between oxygen and hydrogen, which is more electronegative? Oxygen. So the bond between oxygen and hydrogen taken towards oxygen, so oxygen will get -1 charge, hydrogen will get +1 charge with respect to OH bond. Here also hydrogen +1, oxygen -1 with respect to this OH bond. Now what about with respect to these bonds? Similarly, oxygen is more electronegative taken towards oxygen, so -1 charge, so sulfur will be +1 charge. Here also sulfur +1 and oxygen -1. Like this you need to write their respective oxidation state with respect to each of the bond. Okay, now what is the net charge present on this sulfur? See, +1 +2, it means +3, again +1, it means +4 and again +2. So total charge present on the center sulfur is +6. So this is the charge or this is the oxidation state of sulfur in sulfuric acid. Hope it is clear. Now one more thing. What about the oxidation state of this oxygen atom? See, -1 with respect to 2 bonds, this side bond, that side bond. So oxygen will be -2 here. Here also oxygen will be -2 and these 2 oxygens also -2 charge. All oxygen atoms here are -2 charge. What about 2 hydrogens? Each are with +1 charge. Hope it is also clear. Now say here I am making a generalized formula so that you can use it every time whenever you wanted to find average oxidation state of any molecule, atom in any molecule. So 2 hydrogen atom, each one is having +1 charge. So how we are saying it is plus 1? It's purely based on the electronegativity difference between the that hydrogen atom and its attached atom. Okay. Then next, X is a sulfur oxidation state. Let us consider, we need to find that X value. So 4 oxygen atoms are there, each oxygen atom charge is -2. See, overall molecule is a neutral one, so it is equals to 0, right? So now find the value of this X here. So how much you will be getting? So 4 to the 8, this will be -8, and here it will be +2. Overall molecule is neutral, so you need to take it as equals to 0. Hope it is clear. So now what is the value here you will be getting? So it will be -6. If I send that side, it will be +6. So this is how you need to find the oxidation state of sulfur or any atom in a given molecule. Hope it is clear now. Now same concept you can apply to this, and I want the answer in the comment box for this particular formula. KMnO4, oxidation state of manganese in this KMnO4, this manganese oxidation state, from anyone in the comment box. Yes. So how can we find this? Remember alkali metals. Remember alkali metals in all its combined states. It means whenever an alkali metal forms some compounds or involves in some compounds, always remember alkali metals will be having +1 oxidation state, right? Okay. So it will be +1. Now I told you to find for manganese. Okay. So consider for manganese it is X. Okay, that X value we need to find, and potassium atoms are 1, so 1 into +1 charge. Okay. If potassiums are 2, so 2 into +1, like that. Okay. And the next oxygen atoms 4 are there, each one is -2. Overall molecule is neutral, so equals to 0. Okay. Then what will be the value of X here? So X will be -8 + 1. Okay. It will be here it is -7. If I send this side, it will become +7. So +7 is the oxidation state of manganese. Hope it is clear, right? Now I will be showing you one question directly. Okay. After that we will do few more questions. I just wanted an answer for this question, which is asked in NEET 2018. Anyone? Shalini, feel free to ask your question or express your answer for the given question in the chat box. So this point valid for all the online students, those who are watching in live. Okay. So tell me answer for this particular question. Find it properly. See, correct order of nitrogen compounds in its decreasing order of their oxidation state. It means what is our central atom here? Nitrogen atom. So you need to find the oxidation states of this nitrogen in each of this case. So how can we do? So first case, let us say these are the 4 options, so 4 compounds in each option. Let us take first HNO3. How much you will get? -2 3 6. -6, this is +1. So how much it is? Again remaining is -5. Okay. Overall molecule is neutral, means so we need to put on the nitrogen as +5, right? Like this we have to take. Okay. This is a way, or you just simply use the formula and you will get this value only. Okay. In NH4Cl, NH4Cl, we know Cl chloride ion it will be, okay. So -1. Okay. 4 hydrogens are there. 4. So it will be how much?
-3 overall.
So this will be +4. It means -1 is neutralized one number. So it will be -3 on nitrogen. Hope it is also clear. Okay. Then next, NO. NO case how much? NO. It means oxygen minus. See, out of this oxygen is more electronegative.
-2.
This will be +2. Okay. Next, N2 we have. See, whenever an atom combined with itself, the charge, the arbitrary charge or the oxidation state will be 0 for that molecule. So now arrange them based on the decreasing order, which is least here. So second option, this NH3 NH4Cl is the least. Decreasing order means this should be the least. Highest is which one? HNO3 is the highest one. Okay, and after that NO and N2, that's it. So where do we have this kind of order? So it is option number 3. Hope it is also clear. Right. Now I hope you got some basic idea how to find oxidation states. Now I will be giving you few questions that were asked in the exams previously. CrO5. Find the oxidation state of chromium in this case. Okay, and next. See, if you directly do like that, so your answer will be definitely wrong. Okay, and after this, so tell me for this K2Cr2O7. First you tell me in this. So these are the 3 compounds I have taken. So feel free to answer the questions which I am writing over here. Second one also 10? Wrong. Third one? So now let us start with second question. Okay. So here for chromium we need to find. So this is the atom where I wanted to ask you. This central atoms I am asking, chromium in this case. Okay. So for 2 chromiums, so 2x. Okay. 7 oxygen atoms. So 7 into minus 2. Here we have 2 potassium atom, each one plus 1 charge. Overall molecule is neutral, so equals to 0. Okay. So how much you will get? 2 plus 2x minus 14 equals to 0. So this will be 2x minus 12, 0, x will be 12 by 2, it will be plus 6. So what is the oxidation state of chromium here? Plus 6. Hope it is also clear, right? So now one more thing. Now tell me in this case and in this case how can we do? So I wanted to find for chromium. Okay, so consider oxidation state of chromium is x, we need to find that value. So 5 oxygens are there, 5 into minus 2 if you take, overall molecule is 0, so x will be plus 10. So if you do general average, calculating average oxidation state formula using average oxidation state formula like this, your answer will be wrong here. Okay, so you can write this and put a wrong mark to this. Okay, because you need to know the basic condition here. So what is the basic condition? Always remember note point, you can write a note point. The oxidation state of an element should not exceed its valency, its maximum valency electron. Valence electron. For example, electron or electron count you can say. For example, what is the electronic configuration of chromium here? Atomic number is 24. Okay, so it will be having argon, atomic number is 18 here. After this, whatever the electrons are there, those are the valence electrons for chromium. So we can write 3d5, 4s1. This is the valence electrons. So maximum how many valence electrons are there? Chromium 6. So the maximum oxidation state shown by the chromium is how much now? 6. It means whenever chromium is participating, whenever chromium is forming some compounds, these are the only electrons which are taking part in chemical bond formation. These are the maximum number of electrons taking part in chemical bond formation, but not this inner core electrons. So what is the maximum possibility? Plus 6. Okay. So here we got plus 10. Is that correct? No. So this is the main important fundamental consideration. Okay. So as per that, this formula, this calculation is wrong. So in these cases, these are the special cases where you need to find their oxidation state based on their structure. Okay. So based on the structure means, so CrO5 here, the structure will be having butterfly structure. So butterfly structure, how will we getting? So see, make a structure, for our understanding, make a structure in order to get oxidation state either +6 or lower than that. Okay, so I am making a structure, look here. So I am writing 5 oxygen atoms are there, here I am writing 1 oxygen, here I am writing 1 more oxygen. So between them I am making a bond. So this is getting a peroxy linkage now, OO type linkage. So now here -1 charge, here also -1 charge. Similarly this side also I am making 1 more peroxy linkage like this. So here also -1, here also -1. So as of now 4 oxygens are over, so each one -1, chromium will be +4 now as of here. 1 more oxygen is there. So if you put a double bond, no issues at all, because +6 is the maximum. Now we got a +6 one with -2 here, +6 here overall, right? So this is a structure, you can call it as butterfly structure. Okay, hope it is clear, right? Yeah, so those who are in online, if the concept is clear, just click on the like button so that I can confirm you are following the class. Yes, so the next, similar to this, now tell me what is the maximum possible oxidation state for sulfur in H2S2O8. So how many valency electrons are there in sulfur? Write the general electronic configuration for 16th group. Sulfur belongs to 16th group now, so write it according to that. How do we write? So sulfur, it will be 3s2 3p4, like NS2 NP4. Okay, so 6 electrons are there. So maximum possible oxidation state is how much? Maximum oxidation state for sulfur is how much? +6. Okay, this number should not be exceeded. Okay, so now if you do this average, this formula, so tell me by calculating normal way, you will be getting how much? You will be getting +7. Once try. But +7 is not possible now. So if it is not possible, we need to look into its structure. Structure means generally we can expect there might be existence of peroxy linkage, that's it. Okay, number should be decreased, oxidation number should be decreased, means peroxy linkage should be present. Okay, so now how can you do this? So sulfur atom I am writing here, again 1 more sulfur I am writing here. Okay, so here 1 oxygen, here 1 oxygen, again 1 more oxygen, 1 more oxygen, 4 over. Okay, so OH group, here 1 OH group, here 1 OH group. How many over? 6 over. 2 hydrogens are also over. 2 oxygens are remaining. So I am inserting here, making a peroxy linkage. Okay, so this is the bond we have. So this is -2, this is +1, here also +1, this is -2, here -2, -2, -2, -2, this is -1, -1. So these oxygens are peroxy bond, peroxy. These normal terminal oxygens are there, na? These all are just oxides. These are peroxides. So what is this oxygens? Peroxides. These are oxides. Oxides you can say. So peroxides. So oxides will be having oxidation state -2. Peroxides will be having -1. Each oxygen will be -1. Okay. So now what is the central sulfur atom's oxidation state here you can consider? So -2 means +4. Again here -1 means +5. Here -1 means +6. Here also +6. Like this you need to calculate. Hope it is also clear. Now it is reaching maximum but not exceeding the maximum state, right? So this is also clear now. Fine. Here I will be giving you one trick also, just to find number of peroxy linkages possible. So how can you do that number of peroxy linkages possible? So always remember, so this is just a trick, it may not be applicable all the cases. Sometimes you can get a fault answer also, purely you need to know the structure, but let us take this formula also. Number of peroxy linkages is equals to the calculated oxidation state. Calculated means now you got an average oxidation state, you got now like using the formula. So you just take average oxidation state or just write calculated oxidation, both are same only, minus maximum oxidation state. oxidation state. So what is the average oxidation state here we got? If you calculated 7 you got. What is the maximum oxidation state this sulfur can show? So 1. So number of peroxyl linkages are 1 like that. Okay, so let's move further. So just identify which reaction is not a redox reaction. Which reaction is not a redox reaction? See, just what we need to do. Redox reaction means what? In that complete reaction process, there should be one species undergo oxidation, other should be reduced. So if that is not happening, you have to choose that as the answer. So just look into the options. Barium chloride. So here it is +2. This is -1. So this is again. This is +2. This is -1. This is +1. This is +6. This is -2. Okay. Again barium remains same only here +2. Okay. So barium not undergoing any change. Sulfur again +6, that is also not changing. Oxygen also not changing. Sodium also not changing. Chloride also not changing. This is not a redox reaction. So we can go with option number 1 as the answer. Yes. You can cross verify other options too. Zinc in its elemental state, so 0. Copper here it is +2. Sulfur +6. Okay. Sulfate remaining same. So no change in the oxidation state of sulfur, but copper is changing from +2 to 0. Zinc is from 0 to +2. So what I can say from 0 to +2 means oxidation. Copper +2 to copper means reduction. So I can say this is a redox reaction. Like that, if you solve these three options, you will get this as redox reaction. But first one won't be a redox. So you can go with option number 1. Hope this is also clear. Yeah. Now let us understand the concept of oxidizing agent and reducing agent. Okay. So now, what is an oxidizing agent? What is a reducing agent? Okay. See.
Itself is called as oxidizing agent, and agent which oxidizes itself is called reducing agent.
See, oxidizing agents are those compounds which can oxidize others and reduces itself. Okay. See, for example, KMNO4 here we have. So this KMNO4, okay. So KMNO4 I am writing. KMNO4. So what is the oxidation state of manganese here? If you calculate 4 to the 8 -8 +1, so it will be +7. Okay. So now I just wanted to ask one more question also. What is the maximum oxidation state possible for manganese? How can you find that? Just find the valence electrons, that's it. So you will get +7. See, manganese atomic number is how much? 25 now. So I will be telling you the trick for remembering the electronic configuration also. So 25 now. So just write 3d5, 25, right? 3d5, 4s2. 3d5, 4s2. See, 5 is there now, put it on 3d. 3d5, 4s. So s, put this 2. Like that. Easy to remember? Okay. So now it is +7 means how many valence electrons are there?
7.
Total 7. Remove that 7. So it means, is there any valence electrons? No. So what is the maximum oxidation state possible for manganese? +7. Okay. So beyond that it is not possible. Okay. So now manganese here, when we treat it with this oxalate ion, so this will be undergoes reduction like this, Mn+2, and whatever the carbon here we have, just find the oxidation state of this carbon. Fast. So you will be getting plus 3 as the oxidation state of carbon in this oxalate. Okay, and here how much it is? +4 in carbon dioxide. Now see, this is the species, permanganate is a species undergoing what process? Manganese +7 is converting into +2. What process it is? Reduce in number, na? So I can say this is undergoing reduction. Okay, so it is undergoing reduction. Okay, so this is a species undergoing reduction. Now what about this carbon converting into +4? Number is increasing, na? So which process is this? Oxidation, you can remember. Okay, so now what you need to understand, this is a species undergoing reduction and oxidizing others. So what we have studied, oxidizing agents are those compounds which oxidizes others, reduces itself. See, this is the species oxidizing this oxalate ion and undergoing reduction itself. So what I can call this KMnO4 as? Oxidizing agent. Okay. Now can you define what do we mean by reducing agent?
The reducing agents are the compounds which oxidize themselves and reduce other compounds.
So reducing agent. So this is the agent which reduces others, oxidizes itself. Now this species +3 is converting into +4. It means oxidizing itself, and this is a species reducing this one as +7 to +2. So can I say this is reducing agent? Yes. Okay. So it means in a redox reaction there will be one oxidizing agent, there will be one reducing agent. Okay. The species which reduces others and oxidizes itself should be called as reducing agent. Reduces others means it is an agent which is reducing others. You should understand. So now here one thing you need to know here, how can we decide whether a particular molecule will be act as oxidizing agent, reducing agent, or both? Do you getting what I am asking? See, I given KMnO4 and I am saying this is an oxidizing agent. How can we say this is only act as reducing agent? See, what is the oxidation state of manganese over here? +7. So +7, right? So now this +7, is there any electrons here again in the manganese? We have 3d 0, 4s also 0. There is empty orbital without any electrons. There is no electrons to lost again. Okay, but there is a possibility to gain the electrons. See, now tell me, define again reducing agent means?
Which oxidizes itself and reduces other compounds.
See, reduces others means it is converting into Mn+2 means it is gaining electrons, right? It is gaining 5 electrons again, right? Okay, we have empty orbitals to accommodate this whatever the gained electrons in this empty orbital. So it can gain the electron, but there is no electrons to lose the right? So Mn+7, there is no possibility to lose the electron, therefore it cannot act as reducing agent, but it can act as only oxidizing agent. So what we can conclude from this part, if an element, if a species, see, if a species having oxidation state equals to its maximum oxidation state, it can only act as oxidizing agent but not as a reducing agent. Similar story you can come for the like reducing agent. If an element is in its minimum oxidation, okay, see, if an oxidation state is equals to its minimum oxidation state, then that can be act as only but not as oxidizing agent. Okay, hope it is also clear. These points to be remembered. Okay, if an element having intermediate oxidation state, for example here a species having state +2, now it can undergo oxidation state maximum to +4, and let us say it is can undergo maximum minimum to -2. Now this is the intermediate now. Both possibilities are there. So those kind of species can act as both oxidizing agent as well as reducing agent.
Then how to identify the minimum oxidation state?
Minimum, for example, okay, good question. For example, carbon, let us understand. Okay, otherwise nitrogen is a more convenient one. Okay, anything is fine here. What is the electronic configuration for these? Valency, you tell me. after helium 2s2 2p3, only these electrons will participate in chemical reactions, no? So write their orbital representation for more clear understanding. Like this we can understand, right? Now what is the maximum possibility, how many maximum electrons it can gain by the nitrogen? What is the maximum possibility? 3 electrons. So we got only 3 orbitals are halfly filled, so it can take 1 electron maximum. There is no 2d orbital, right? Yes. To accommodate, there is no 2d orbital. So only maximum how much it can gain? 3. So it becomes, nitrogen becomes, by gaining 3 it becomes n minus 3. So this will be the minimum oxidation state of nitrogen. Hope it is clear. Now what is its maximum oxidation state?
5.
How many valence electrons are there? 5. So maximum can be plus 5, minimum can be minus 3. Now similarly you tell me for carbon again. What is the minimum and maximum oxidation state possible here? So for this also write its electronic configuration, valency 2s2 2p2, 4 electrons it has, okay, p orbital can accommodate maximum 6, but it is having only 4, 2, it means remaining 4 can be gained, okay. So it has capability to gain 4 electrons and becomes minus 4. So this is the minimum oxidation state. Now what is its maximum oxidation state? It has 2 plus 2, 4 electrons it has, it can lose all 4 and become C plus 4. This is the maximum, this is the minimum oxidation state. Hope it is clear? Yes. Okay. Now, yes. So let us move further. Yes. No confusions, no? So this is a basic definition about reducing agent. So what is the note point I have told you? If the oxidation state of an element is in intermediate, it can act as both oxidizing agent, reducing agent. See, for oxygen, like this we have. Here it minus 1 we have. So it can go to H2O, or it can convert into, so here it is minus 2, this is the minimum, or it can go to increase its number to O2, like that, right? Here it is 0, number is reduced here, number is increased here, right? So I can say H2O2 can act as both oxidizing as well as reducing agent. Hope it is clear. Now there are different types of redox reactions, okay. So we have different types. Yes. Of that I am explaining like intramolecular redox reaction, intermolecular redox reaction, like that we have, but I am not going to discuss the basic one. I am just giving you the one important. There are two important, one is disproportionation, another one is comproportionation redox reaction, that has to be studied by everyone, okay, and these are important also. So redox reactions in which same element present in particular compound in a definite oxidation state is oxidized as well as reduced. For see, if you wanted to understand more, for example phosphorus here we have, or sulfur we have in this case. So for example any element, let us say A is an element, okay. Now this A element having, let us say, 0 oxidation state, now within the reaction undergoing oxidation and undergoing reduction. Let us say A becoming A plus some number, let us say plus 3, and here A becoming some A minus some 2 or 3, something like this. Same species undergoing both oxidation, reduction simultaneously within the reaction. So I can say this kind of reactions are examples of disproportionation reactions, okay. Now here we have few examples. See, just now we have discussed about H2O2, hydrogen peroxide. Now it can undergo reduction, oxidation. So here it is minus 2, minus 1, minus 2, 0, right? So oxidation, if you consider here, minus 1 is changing to minus 2, it means what is this process I can say? This process is reduction and this process is oxidation. So same process, both processes are involving in the same reaction, so it is a disproportionation reaction, okay. Next, halogens, generally chlorine, X2 means chlorine, bromine, iodine. So what happens, this chlorine in basic medium, so undergoes disproportionation reactions to form Cl minus as well as some ClO hypohalides like this. Okay, so these are the two species. Here -1, it is 0, here it is +1. So what are the numbers changed here? -1, 0. So this I can say oxidation, this I can say reduction. Hope it is also clear. So again, here you can look in this point. Again, these reactions, again this is JEE advanced questions. Here you can see this kind of differences, dilute and concentrated mentioned. Okay, so what makes the difference? In dilute we will be getting OX, like HOCl. If I use chlorine, you will get something like this, HOCl. If I use concentrated base, okay, here we will be getting HClO3 kind of product. Chlorate is a product. Here it is hypochlorous acid. Hypochlorous acid, it is chlorate. Okay, that is the difference. Okay, you need to understand, and you can make a note of these two reactions also. And see, F2 do not undergo disproportionation reaction as it is a most electronegative element. Okay, so just make a note of this all reactions. See, P4 in basic medium undergoing oxidation as well as reduction to form this paspin and this like oxo acid of phosphorus. Yes. So manganese, here you can see what is the oxidation state of manganese in this case? No, it is, tell me, here in this compound, here it is +6, now it is forming +7 as well as +4, okay, +7 and +4. So can we say disproportionation? Yes. So all these are very important reactions, you can make a note of this, all these reactions. Okay. So why I am saying important means, so you can expect a question like finding the n factor in these questions. What is the number of electrons changed? That we will be finding in the next classes, upcoming classes, after learning about equivalence. Yes. So one last discussion in this session. We will discuss about comproportionation reactions and we will wind up this for the next session. Yes. So done? So what about comproportionation reaction? These are reverse of disproportionation reaction. Reverse of disproportionation means what? See in this example, if you find the oxidation state for nitrogen, here it will be -3, here it will be +3. Okay, so this oxidation state, same element having different oxidation state, so forming same oxidation state. So -3 +3, both are forming to same oxidation state. You can read here. See, nitrogen in this compound has this oxidation state which is not a definite value, so it is not a disproportionation reaction, it is an example of comproportionation, that is, which is a class of disproportionation reaction in which an element from two different oxidation states, see, from two different oxidation state get converts into single oxidation state, only we are getting single oxidation state. Okay, so what I told you, comproportionation reactions are of reverse of disproportionation. If this element forms two different
oxygen into that,
we can say that is disproportionation. If two different oxidation state containing compound is converting into one oxidation state containing compound, we can say that is comproportionation. Yes. So these are the two important things you need to remember. Yes. So this is about the session, and if you have any queries, feel free to ask in the comment box. If no doubts, yes. So you can stay connected with us, and if you like the content, please click on the like button, and thank you for watching.